We said that instruction hazard. So, as I said, the instruction hazard will occur if there is a cache miss. Okay? So, that means instruction is not there. So, therefore, there won't be the continuous flow of the instruction. So, for that what we can do it? We prefetch the instruction and we can store the instruction. If in future there is a cache miss, so it will take time, but within this time period what we can do? We can send the instruction to the decoding unit and subsequently the execution unit. Okay. So, for that is what is done is there is something called instruction queue. After the fetch unit we can have a queue where we can keep the instruction for future use. Okay. So, if there is any cache miss here, so this flow will be stopped, but because we already brought some instruction already, so there will be continuous flow of the instruction, obviously length of this queue will be reduced. So, that is the one solution, okay, to avoid the cache miss. Okay. So, this is something called prefetching. So, whenever you do not need the instruction, but before that you are fetching the instruction. So, it may go wrong, because if there is a branch instruction, then obviously this thing might be wrong. Some of the instruction may not be required. Okay. So, this is a kind of solution to address the cache miss problem. So, this is not very difficult part. So, earlier what had you did not have this part, that is why there is a gap between execution, because you do not have the instruction. Now, we are pumping the more instruction and keeping in some place. If there is no instruction, then we will take out the instruction from that queue. So, that is a so simple solution. Okay. So, now conditional branch, I told that conditional branch situation, and now I will restate that part, because some of you is I feel ki not understood properly. Okay. So, this is solution is something called delayed branch. What we will do it? We will reorder the instruction. How we will reorder? Just we will see one example here. See, this is the program here. As I said, this is like you have a counter and 5 times I want to shift the R1, register R1. And this is very important place, that after the branch instruction, this is a branch instruction. So, let me tell you what does it mean by this branch instruction. So, branch instruction, whenever you write the branch equal to 0, so it will find whether the previous operation is 0 or not. What is the previous operation? That is decrement R2. Decrement R2 means, so whenever the value decremented and it becomes 0, so there will be in the processor there will be there is a bit is called the 0 bit. If previous results is 0, then that flag will be on, that means 1. So, based on that it can decided, okay, the previous operation was actually previous operation, whatever the operation, so it becomes 0. So, now if it is successful, that means then it will jump to the location where it is pointed, like this is this, it will point to this location and it has the again the shift operation. And just immediately the instruction, this instruction is called something the slot, okay, branch delay slot. What will happen if you go normally while executing this instruction, next instruction also will be fetched, and then while that instruction is getting executed, second instruction will be decoded, that we have seen it. But after realizing that this instruction should have not been executed, because it is a branch instruction, instead of that it should have been executed this part, that is shift left. So, then what ideally we did, we have to discard whatever the execution happened, fetch, decode, and this everything you have to discard. So, we want to address that without discarding, how we can make the that pipeline stream, we can make the pipeline smooth. So, that is we are trying to address. So, what do you do it? Let us say value of R2 is, let us say 2. So, then what will happen? Shift left. So, we will have shift left will execute, then decrement R2 will execute decrement R2, right. then it will check branch. So, it will check branch 0. So, what you will see, it is not 0. So, it is 1. So, then again it will execute shift left. So, it will execute shift left, again it will decrement. So, DCR R2, now it is 0, no doubt, right, it is 0. So, then it will check branch, okay. It will check, now it is 0. So, then which instruction will be executed? Next instruction will be executed add. So, add, okay, only add. So, this is the sequence. If you have the value of R2 is something like that, and R1 will be shifted twice, that is all. What we will do it? We will reorder this part and we will show that if we reorder it, we will have the same results. Then you will not have any objection that result is changing because of you reorder it. Okay, that is first we will check it. So, let us say this is the value. What is the value of R2? R2 is 2, here R2 become 0. Now, what is the decrement R2? So, it is decremented. So, what is the statement, that is DCR R2 and value of R2 is now 1. Next, what we did? Branch 0. So, branch 0 means where it will branch? It will go to the loop 1. So, it will execute BR, okay. It will check it. So, it is false, right. So, it is not. So, then it will move here, but within this time what will happen? This instruction also will be fetched. So, therefore, it will be executed shift R1. Will it be executed or no? This is okay. So, how many times shift we executed? Twice in this part. We executed twice, right, and that was the objective. So, with this one it is done, but here we have the problem, we are not convinced, right. So, first you are saying decremented, then branch and then shift, okay. So, either shift will be executed or not here in this case. So, shift will not be executed, yes or no, you have to yes, no or 0.5. So, apparently it seems that it will not be executed. So, what we have to do? We have to imagine, not imagine, we have to think it that instruction is executed into 4 phases. Okay, then only we will understand why this is happening. So, for simplicity, what we will do it? We imagine that instruction is executed into 2 phases, only fetch and execute. So, therefore, we will come here. Okay. So, what was the order? Order was first decrement, there is branch, okay, and then there was shift. Okay, that was the part here. So, decrement, branch, shift and then add. This was the instruction. So, now I said the instruction has 2 phases. So, if any majority of you already understood, until unless you say that we understood, I will keep on saying the same thing. Okay. You understood what I am saying. So, you have to speak out that okay, he is understanding, please do not waste my time, you go forward if you really understand. Okay. So, here we go. So, let us say we have 2 phases, that is the decrement R2. So, then it started fetching, it fetched it. Then in the second phase it is getting executed. At the same time branch instruction will be fetched. Okay. So, and the third clock cycle this will be executed at the same time. What will happen? Branch. So, what we said ki if you go back little just once. So, after branch actually there was a loop. Loop means that label was there, it should go to that particular location. So, ideally what happened, after that it should execute decrement, because if there is a branch. So, within the, when it will be decremented, so within when it is getting executed, because of this pipelining, next instruction, the next instruction will also will have the fetch part. So, fetch is done. Now, after that it realize, after this one it realize that it is a branch instruction. So, then it will go for again decrementing the value of R2. So, that instruction will be fetched. So, within this time what will happen? Let it allow, no, do not discard it, because it was the necessary. In original program that was the part. So, therefore, we should not this part, we should not discard this part. If you allow this part, all instruction is getting executed, all 3 instructions are getting executed, because that is we wanted. Okay. So, here this all 3 are getting executed. My objective is, what was the objective? Objective that we should not discard any instruction if there is branch, because branch instruction should be extracted and it should go. So, yes, after this one we realize this is a branch instruction, we will fetch that branch instruction. So, this instruction ideally if you do not use this technique, reordering technique, we should have discarded, but here no need for discarding, because if you allow it, if you allow to execute this part, then whatever we wanted to do using non-pipelining, that is getting done. So, this program what we wanted to do? We wanted to shift R1 twice, that is main objective. Now, what I did, we changed the order. Now, we will see whether we are able to do the operation, which operation, that shifting R1 twice or not, that we will see. So, now you go here. So, first what we do, we decrement it. Now, branch instruction started executing fetch, and while executing here branch instruction, after that it will realize that branch instruction and then it will execute. That means, it will branch if there is need of branch, so it will be branched. So, after that it realize that the in between whatever instruction it needs to be discarded, but it is not required, because if we allow it, then shift operation, this operation will be done. So, it is one time, we want that it should be done twice. So, now what will happen? So, again branch decrement will operate it, because that is the jump instruction here. So, this fetch will be done, again it will execute here decrement. Now, value of R1 is what? Value of R1 is 0, because it decrement first, it was 2, now it is 1. So, it is done, and now again it start decrementing. So, value is 0 now. So, value is 0 here, again branch instruction is there, and while executing this branch instruction, next also that delay slot part is getting executed. What is that? That is shift R1. So, after that it realize, okay, it should not be branch. So, then which instruction will be executed? That is the add instruction. So, after that it fetch the add instruction. So, let it allow, but within this time shift is done. So, how many times shift is done? Twice. So, what was our objective? That shift should be done twice if you go sequential on order. So, therefore, we are not changing any results. It appears that because we change, it's when we see that instruction is as a single part, then it might be problem, but it is not that. Instruction has 4 pages and then we should execute concurrently, then only we will realize. So, in between whatever the instruction come, no need for discarding. Our objective to execute that shift twice. So, we did with this one. You take an example of r equal to 3. First case no problem, we can execute no doubt. So, now you see for r equal to 3 what happened here. So, what is the value of r? R equal to 3. First statement is decremented. So, value now become 2. Okay. So, while executing this part, branch will come here. So, while executing branch, so that delay slot part will come, delay slot is nothing but the shift. So, here what is the value? Now, decrement value is 2. So, here this part will be executed and it will branch to again decrement. So, now value 2 to reduce to 1. Okay. Now, a branch will be executed and it will realize that again there is need for branch because it is not 0. Within this time, this delay slot instruction will be executed. Okay. So, after that, instead of add, again it will be decremented because it is not 0. So, again decrement will be done here, same sequence, decrement will be done, and then again branch will come, and then branch is now it will not take branch will not take place because value is 0. Okay, because we decremented 3 times, and when it will go to the add instruction, within this time this delay slot instruction will be executed, that is the shift. So, shift is also operating thrice, that was our objective, and there won't be any change in the results also. So, it will keep on increasing, I do not know what will be the last R value. So, this is not a complex mathematics, right, just simple text stories I am telling. Okay. So, if it is complex mathematics, okay, I am not also very strong in mathematics. Okay. So, if it is complex mathematics, okay, we can take rest and then again we come back to understand. This is simple logic I am saying, just in form of text. What we can do it? So, for this 2 stage is much easier to understand. Now, if I go for 4 stage, okay, we can try whether it may happen that you understood the 4 stage and then again come back to 2 stage and then you understood. So, what will happen? In that case, actually you have to discard some of the instruction. We can minimize the penalty, but you need to discard some of the thing, because while executing, I do not want to make things complex. Okay. So, you should understand this part. Okay. So, therefore, for delayed branch is nothing but you arrange the instruction in such a way that in delay slot you can have an effective instruction. So, no need to discard that instruction. So, we have 3 instruction in the loop. What we have to see? We have to see whether each instructions are getting executed exactly the same number of time we wish to see. In value of R, initially it was 2. So, when we do sequentially, so we have seen that each instruction within that loop are getting each instruction is getting executed twice. Now, if we change the order, if you miss any one of them, then obviously it is not exactly the result will not be the same of that. Not only that, if you see the instruction dependency between 2 instruction, in this example there is no dependency, in a sense that when we shift R1, so that result is not affecting to others values. It is very simple to check whether next instruction is having any source part is involved with other in the what is called operand part of the next instruction. So, there is no case, we are instructing the same instruction. So, same number of time and they are almost independent except that 2 part. What is that 2 instruction? That decrement and branch. These you cannot apart each other, because if you see carefully here, the decrement and branch are consecutive. We are not changing, because branch will happen based on the previous execution and previous execution is decrement. So, here order is same, here order is same. Only order I change is here, shift was found, it was in the first position, but I put in the second position. But it's apparently it looks that because loop is here, it will not come here in the shift. But you have to shift you have to see that instructions are getting executed into phases, and it is happening concurrently. So, when one instruction is in decoding phase, other instruction is in fetching phase. That is why two instructions are occurring, while this instruction is yet to realize that where to branch. Within that, second instruction execution will complete, or second instruction is in the fetch mode and it is in decoding mode when other is in execution mode. That is we learned, right. If there are two consecutive instruction, one is in execution mode, other will go in the decoding mode. If one is in the writing mode, other next instruction will go in the execution mode. So, that is why in this figure what we see, that when branch is in fetch execution mode, that next instruction is going in fetch mode. Now, when it realize that there is a branch, so then it will go to the desired location, otherwise it will go to the next location, that is add function. Within this time what will happen? This execution we can allow, we could have discarded, after realizing we could have discarded, okay. But that we do not want. To address that problem, we rearrange it, okay, let it go. So, if we allow them, then we will see that we will get the desired result, because number of time each instruction executed within a loop are exactly the same if you do not use the pipeline. Okay. Only the task is you have to rearrange. So, that task actually should be done by the compiler. So, now we move to the next part, okay. Because we are talking but you do not forget what we are talking, right. So, we are talking about if there is a conditional branch, pipeline will be disturbed, that will create hazard, and to address this problem we are talking so many things here, okay. So, one is the delayed branch reordering, but you can say it is not possible to reorder always. If there is a dependency, you cannot do that. So, it is not the golden solution, okay. So, this is a solution, but this is not the golden solution. So, next we will go next part here, branch prediction. So, it will be good if you predict whether branch will happen or not before executing. So, it is like before happening you have to say the whether branch will happen or not. Based on that, you take you bring that particular instruction. So, if branch is placed, then you go to the particular instruction, that is decrement, otherwise you go to the add. So, that is something called branch prediction. But how do you predict? So, one simplest solution is always you consider there will not be any branch. Then what will happen? Then next instruction always it will be in the pipeline. So, that we will be talking about here. To predict whether or not a particular branch will be taken, simplest form we assume that branch will not take place and continue to fetch the instruction in sequential address order. And when it realize that myself was wrong, so then you discard it. Yeah, until the branch is evaluated, instruction execution along the predicted path must be done on a speculative basis. Okay. What it says, you keep on executing this part, but do not change the register file, because write back is the final solution. You do whatever you like it, but do not change the file. So, whatever the result, intermediate results, like in the data forwarding. So, we have the intermediate results, but not the final results, it is not written. So, what you do, intermediate results you store in temporary register, not the final register. When you realize that yes, that I was right, keep telling that do not jump, so then only you modify that. So, that is the one way for one solution. So, this is something called branch prediction. Speculative execution is something you keep on executing up to even ALU, but do not change the destination value. Then every register value another thing, you keep those value in the temporary register. Okay. So, these are the thing need to be very careful that no processor register or memory locations are updated until it is confirmed that this instruction should indeed be executed. Otherwise, you have to purge those instructions, whatever the value is temporary values and those you have to discard that. So, this is one solution here. This is a situation where incorrectly predicted branch. Okay. So, let us say there is a statement is called compare, and if comparison is greater than 0, then this is a branch. branch to a location ik. So, this predict at this decoding part, it predict that there won't be any branch. Then what will happen? So, next instruction, immediately next instruction will be fetched, and when it executed, then only it will realize that what is the, whether this prediction was right or wrong, whether it will be branch. Unfortunately, it found that okay, it needs to be branch, because earlier we predicted there won't be any branch, and then subsequent instructions are getting executed. Within this time, when it realized within these two instructions are in the pipeline. So, after that what it realized, no, it is the wrong instruction we have chosen. So, therefore, you have to discard this two part, and this is the situation here. Now, question is, if there is a loop for 1000 times, every time you come and check there will be branch, there will be no branch, and every time you will lose this, you have to discard that two instructions. Every time you have to check, whenever there is a check branch. So, every time we assume the next instruction we should fetch, and we fetch these two instruction, and then we have to discard it. So, this is not a very good solution, as you understand. So, instead of that, what we can do it, whenever in a loop, okay, first you check. Okay. So, first you check, okay, there is branch or not. If there is a branch, okay, so then you remember last time we had branch. So, we assume that very likely next time also there will be branch. I said in a class, right, earlier, if there is something called locality of reference. The things will happen, is something called recent past is the good indicator of near future. I told earlier, right. So, someone is sleeping now, so it assume that he will be sleeping after 2 minutes also. So, this is a perfect example of temporal locality, and someone is sleeping, and very likely that his friend sitting in the nearby will also be sleeping. That is a perfect example of spatial locality. So, therefore, when there is a jump, it is assumed that next time also there will be jump. So, at least 1000 times that guy will be right, okay, until or unless it reached the last time. So, last time it found, okay, this was wrong. Okay. So, instead of that, the earlier solution, that every time you assume there won't be jump, there won't be jump. So, every time you discard, now the solution says that you remember what happened last time. So, last time you jump, there was a jump, okay. You assume there was no jump, but there was a jump. So, next time when you encounter, again you check that loop. So, you remember what happened last time. Oh, last time actually it was jump. So, very likely there will be jump. So, keep on jumping 1000 times if the loop start from I equal to 0 to 999. Okay. So, on the last time that will be wrong, and then it will go smoothly. That time also you need to discard, because instead of that it started the jumping instruction. That time also it has to be discarded. So, that solution is something called, this solution is called, we predict always ki there will be jump. There is no change of the statement, right. There will be always, there will no jump, or there will be jump. That is something called static solution. Okay. So, that is something called static branch prediction. You are not predicting because you are assuming that. So, there won't be any jump, and that solution just I said is something called dynamic prediction. So, dynamic prediction is something like that, we are assuming what happened just recently, based on that we are predicting. That also can go wrong, but at the end. Okay. The book I am teaching, that is amateur. So, here let us say just few minutes before what I said ki you have to remember. So, for each branch location will reserve a bit. If last time there is a branch, I will set the bit 1, other it is 0. So, whenever next time we will check for the same branch instruction, I will check what is the value. If it is 1, then again I will go to the branch location. If it is 0, then we won't go. So, therefore, this can be realized using two state machine. So, that two state is, one is say, let us say we can say LT, that is likely to be branch. Okay. So, likely to be taken, branch likely to be taken. Okay. So, it is branch likely to be taken one. Another is something called LNT, likely branch will not be taken. So, it is like okay. So, let us say initially we assume that branch is in a state is LNT, because we are assuming that branch will not take place in static also. Another is something called LT. So, initial state is there LNT. So, we assume that there won't be branch, but I am wrong, because after executing that branch instruction it realized though, so I was wrong. So, then it will move to the LT, likely to be taken. So, it will move to the here if there is branch. So, now if there is a branch, you be in the same state. If there is no branch, branch not taken, what is not branch taken, NBT. So, in that case it will come to the LNT, and if branch not taken, it will be in the same state. So, this is simple. You use, as I said, that you use one bit, because two states. If there is a branch, you put the value 1, next time you check the value. That is much better solution than previous one. It has also drawback. Okay. What is the drawback? Let us say you want to execute the loop, that 1000 times loop 2-3 times with different data. It is possible, right? Let us say that loop is within a function, and you are calling the function with different argument. It is very likely, right? Now, every time whenever it start the loop, here it start the loop, it will start with LNT. So, LNT, and then it will check it, it will go branch, and last time when it executed, so it was in again the value is changed. So, again it will not go. What I wanted to say is, so when the branch not happened, the value is again LNT, again it is becoming 0. Now, again you wish to execute the same loop with different parameters. So, what should be, what likely to be done, likely to happen, it should branch, because I want to execute the entire program earlier also executed, and I want to execute again the same loop. So, it will be good if the value is 1 instead of 0, because then it will directly come to the LT, likely to be branch, but that will not happen here. So, every time whenever it start from the new loop, so let us say you call 20 times the same function with different argument, different data, okay, value of the argument, then at least 20 times this will be wrong. To solve that problem, instead of that, what is done, instead of 2 state machine, you use 4 state machine, not 3 states. So, instead of 2 state machine, you use 4 state machine. So, then you invest 2 bits, instead of 1 bit, you use 2 bits. You see, and then what are the 4 state? Strongly branch, likely to be, these 2 are there, and then adding with strongly not to be branch, and strongly to be branch. So, in that scenario, what will happen? It will check twice, last 2 time it will check. If there is a branch, then automatically it will be branch. Okay. So, state diagram will be something like that. Okay. So, let us say this is 4 state is something called strong likely to be taken, that branch strongly it is suggested that branch will happen. Okay. So, this is something called strong likely to be taken. Okay. LT is as usual, and then we talk about LNTs as usual, and then SNT. Okay. SNT, strong likely not to be taken. So, here we have 4 state. So, what is, we start with LNT. If there is a branch, so it will go to the ST, and if there is a branch, it will be in the same state. Okay. if there is one not branch, so it will go here, this is LT, this will be branch not taken. If there is branch, obviously this part earlier we talked, so then it will go to the branch taken. So now if this is the situation here, if branch not taken, here obviously if branch not taken, it will be here. So this is SNT. So here is branch not taken and so on. So here idea is that it will check twice. Say let us say branch taken, it is not taken, again if it is not taken, so it will go to the strongly it will not taken. So I stop this point. Okay. So next class I will start from this figure.